Most graph problems seem complicated, but many of them boil down to one simple question. Is there a cycle? And LeetCode 207 course schedule is no different. So we're given one variable here, num courses for the number of courses we have to take, and the second variable is prerequisites, where each pair represents a course and a prerequisite. So in this example here, we see in order to take course A, we must take course B. All right. We could think about this problem in relation to graphs. We could think about each course as a node in a graph and every prerequisite as a directed edge. So in this example here, we have course 0 and course 1. And if we look at the prerequisites, we say, in order to take course 1, we need to take course 0. So in order to get to 1, there's a directed edge from course 0. And we see course 0 has no prerequisites, so we can just take it. We've taken course 0, and now we see to take course 1, we need to take course 0, which we've already taken, so we can take both courses, and we return true because all the courses have been taken. But let me show you a counter example. Same idea here. We have course 0, and we have course 1 here. In order to take course 1, we have to take course 0. So the only way to get to the 1 node is from 0. So there's a directed edge. And you say, in order to take course 0, we have to take course 1. So there's a directed edge from course 1 to 0. As you can see, this is an endless cycle because we just go back and forth, back and forth. So that means we can't take either one of these courses. So we return false. So when you think about the question in relationship to graphs, we really see that it's really asking, is there a cycle in this directed graph, or is this directed graph acyclic? Right? All right, so now that you understand what the question is asking and how to relate it to graphs, let's go into the approach. We're going to use depth first search, or DFS, and each node or course is going to have 3 states. 0, meaning that we haven't taken the course yet. 1, meaning we're attempting to take the course currently. And 2, we've successfully taken the course. All right. And we can represent this with an array called state. And since the courses are labeled 0 through n, we can use this to our advantage and have each of the indices in our state array represent a course in the number of courses. So in this case, the indices 0 will represent course 0, and indice 1 will represent course 1. And they're both set to 0 to default because we haven't taken any courses. And the next thing we're going to need is a way to know what are the prerequisites of each course. In this example here, it's quite simple, but imagine there's many courses and there's multiple prerequisites per course. And what we can use is an adjacency list or a hash map. And the key will be the course and the value will be a list of all the prerequisites. So in this case, we'll have course 1 with a prerequisite of 0, and we have course 0 with a prerequisite of nothing because there's no prerequisites to take course 0. All right, so now let's go into how we'd solve this. First, we want to take all the courses, so we're going to loop through 0 to n because that's all the courses we can take. So we start off at course 0. We say change this into a 1 because we're currently attempting to take it. Next, we want to look through all of its prerequisites. We go through our adjacency list and we say, oh, there's no prerequisites of course 0, so that means we can take it. So we can change this immediately to 2 for successfully taken. Now we go into the next number, 1. We try to take course 1, so we change this to a 1 here, and we loop through its prerequisites. We see that in order to take course 1, we have to take course 0. So we call DFS recursively on course 0, and we see, hey, course 0 has already been taken, as you can see by the 2 here, so we immediately return true because the prerequisite has already been taken. All of the prerequisites in 1 have been taken, therefore we can take course 1. So they're both set to 2. And since all the courses have been taken, we can return true. All right, and let's show a quick counter example here. We have our state array, and we need to make our adjacency list. So for course 1, we need a array of 0. And for course 0, we need to take course 1. And there's 2 courses, so our length of our state will be 2. So first we want to take course 0. So we change it from 0 to 1 because we're currently trying to take that course. We go through 0's prerequisites and we say, hey, we have to take course 1. So we call the same function DFS on course 1, and now we're at course 1. We're trying to take it, so we change this to a 1 as well. We loop through 1's prerequisites and say, hey, we have to take course 0. So we call DFS on course 0. We see that course 0 is currently trying to be taken, and we need it as a prerequisite. So that means we're at a cycle. If we encounter a prerequisite at stage attempting to take, or 1, we immediately return false, because there is a loop or a cycle. All right, so hopefully you understand the high level approach, and we're going to get into how to solve this in code. All right, so let's go over to our text editor. And what I like to do first is create a variable n, and it's going to be set to num courses. It's just so we don't have to keep typing in num courses over and over again. Next, we're going to create our states array. So state, and all it's going to be equal to is an array of zeros, because 0 represents that the course has not been taken. So that should be the default value, times n for a state for every single course. Next, we're going to create our adjacency list. So the program knows what prerequisites each course needs. So adjacency equals default dict, and we're going to set a list in here. And if you don't know how default dict works, all it does is sets the default value to a key that has not been added into the adjacency list or hash map to an empty list. And as you remember, like, let's go back here. 0 was not in the prerequisites as a course, only a prerequisite. And since it has no prerequisites, it wasn't added. All right, and if you don't know how default dict works, all it does is add a default value for a key that was not added into our dictionary or adjacency list. Just like an example here. As you can see, 0 has no prerequisites, so it wasn't in our prerequisites array. But we want it to have an empty array so we can tell the computer that there's no prerequisites for this course. So that's all that does. Next, we need to populate our adjacency list. So we say for C for course, P for prerequisite in prerequisites, and adjacency at C for the course. And since we're holding a list of all the prerequisites, append P for prerequisites. Now what we want to do is create our DFS function. So we define a function DFS, and it's going to take in a course. And since DFS is recursive, we need a base case. So our first base case is if state at course equals 2. That means the course we're currently looking at has already been taken. So that means we're just return true. No need to recompute, right? Next, if the state of the course is 1, then that means we need to return false, because that means we have found a cycle. As you remember here, in order to take course 0, we have to take course 1. So we set that to 1. In order to take course 1, we have to take course 0, which is the course we're currently trying to take. So that means we found a cycle. So we immediately return false, right? If it gets past both of these lines, that means it wasn't 2 and it wasn't 1. So it had to be a 0, which means we haven't taken the course yet. So now we're currently trying to take it. So we set state at course to equal 1. Now we loop through all of its neighbors or prerequisites. So we say for P for prerequisites in adjacency at course. Now we say if DFS of P equals false, return false. So all this is saying is we're looping through the prerequisites, and if the prerequisite returns false, which means there was a cycle, because the only way this function returns false is if there was a cycle, we immediately return false, because that means we can't take all the courses, right? Next, if it gets past this for loop without returning false, that means there was no cycle, so we can successfully take the course. So we set state at course to equal 2, because we can successfully take it, and just return true. All right, so next, before we continue, if any part of this DFS function is confusing, make sure you go back, rewind the video, and make sure you know exactly what each line does. But next, we're going to loop through all the courses and call the DFS function on each of them to know if there's a cycle. So for course in range n, All right, so this will loop through 0 to n for all the courses. And if DFS of course equals false, return false. And as you remember, it only returns false if there is a cycle. So if there is no cycles in any of the courses, we want to return true. So let's run it and see how it goes. And there we go. We solved the problem and it's pretty efficient. And if you have any questions, please comment down below. I'll be happy to answer them. Peace, and make sure you like the video.